Hello, my name is Anh Phan. I'm a biotech student at Palm Beach State College. I'm currently conducting an internship at Florida Atlantic University, the Honors College, under direction of Dr. Eric Dubois. And today I will show you how to make primers for qPCR. There are 4 websites that I list over here needed for this process. The first is Ensemble. This is where you get your genome sequence for any supported species. Multi-island. This is where the multiple sequences are aligned by fluorescence carpet. Primer 3. This is where you can choose a primer sequence from step 2. IDT or integrated DNA technology. This is where you will order your primers. Let's get started. So first, click on this website or type in Ensemble. Okay, paste and go. On this website, this is the genome sequence browsers where you can look up any species that you're interested in. The lower box allows you to type in your genes of interest. So I would type in NR3C1 for instance. Click on the first link. It says NR3C1 zebrafish gene. In here, it tells you the description, where it's located, something about this genes. This genes has 4 transcripts and listed as in this table over here. Click on one and more information about this transcript is the name NR3C1 201. Click on exon. In here, it tells you where it's located and description of this gene. So a little bit of this up here on this website, it tells you the blue coded indicating the translated sequence. The green one or the gray is the flanking sequence or the intron sequence. The red coded for untranslated regions. You want to go ahead and click on download sequence. Click on the first box to deselect all of the options. Click on exon and preview. This allows you to just have the exon nucleotides only. So we go ahead and copy. Open Notepad and paste it down. As you can see in here, there's some letters that are not needed. So go ahead and delete all of this, just leaving the ACTG sequences. Excuse me. Okay, so if you look at on your left window, there's some untranslated regions that might have on your right window. Okay, so what you can do is just copy this. I'll just click on Ctrl C, and over here on the notepad, Ctrl F to looking for the begins of the untranslated regions. And in here, as you can see, this is the untranslated regions. I will delete it. And if you go up here, also there's untranslated regions. So we'll copy Ctrl C, Ctrl F, and paste it there with direction is up. Tells you anything above this is untranslated regions. Okay, so I will delete this, and this on the notepad is a complete sequences of a complete exon sequences of this genome of the genes of interest. Okay, and since this genes NR3C1 has many transcripts, for instance have 4 transcripts, so let's go ahead and click on the second one, NR3C1-202. Click on exon and repeat the same step sequence. Click on download sequence. Click on the very first box to deselect exon and preview. And you need to do the same thing what we did with 201. Okay, same process. Delete any unnecessary wording. Close it, and of course, not to forget, the untranslated region should not be included in this as well. Ctrl V, find where it begins, and delete. Okay, so on my right window under the notepad are 2 complete exon sequences of NR3C1-201 and NR3C1-202. I know that in ensemble there are 4 transcripts of this gene, but I'll just do 2 of them just to show you they are the same process. Okay, so once you finished all of this, you copy the entire sequence in Notepad and open up a new tab and type in multi-allele. Okay, this is the web page. Paste it on this box over here, cut and paste your sequence here below, and click on a color HTML text. Start multi-allele. And in here, this will tell you how much consensus are your 2 sequences that you listed down. And in here, what this color, red color, blue color, and black color means is that for a high consensus value is over 90%, stand for red, indicating in red. Low consensus will indicate in blue, as you can choose any color that you want. For neutral, it is black. So you want your primer sequence a consensus over any sequences that you have or transcripts that you have. So you want to avoid the black and the blue sections over here, so I just click on this and copy it, go over here and find it where they are. So in here, the NR3C1, 201 and 202, the majority of them aligned or consensus over 90%, but after this section in here, sequences, they're not aligned very well. And that's the reason why I don't want my primer sequence within this section, the colorful section over here. So I will copy, since I know where they are, I will copy this. Okay, and I will type in NR3 C1 primer sequence. Okay, paste it down, and I will double check again with the multi-align. Delete this and start multi-align. So in here, the last primer sequence, this is where I begins my primer sequence that I will do later on for primer 3, where I will pick up my prior recommended primers sequence. So in here, as I scroll down, it's aligned until this section over here. And the primer sequence I will use for primer 3 will not have any of this blue section or blue and black sections over here. Okay, so in here I will copy this primer sequence and open a new tab, primer 3. Click on the first link. Okay, you want to choose the product size within this. Okay, I like the optimal primers annealing temperature is within 59. And after I finish all of this, I pick primers. I choose to pick primers. So in here, they will list the primer picking up results, where they have recommended sequences for the forward and reverse primers, where they started, what's the length of the primers. TM stands for the annealing temperature, and like I said, because I preset the annealing temperature is within 59, so this is where I optimize that annealing temperature. Percent of GC should be 50%, no lower than 45, but no higher than 60. Any and 3 here, indicating any self-complementary of the primers. You want this number to be as low as possible. And this is the genome sequence, the sequences recommended. And in here, there are product size and your primer sequence, genome sequence are listed down here. So in here, this is where your forward primers started, and this is where the reverse primers started. And also 4 more options of the primers that you can choose. So how do you know which one you should choose? So first, I will test to see where they are. I will go back to here, Ctrl F for finding. And sometimes it doesn't work because it will shift it down, so you have to delete some of it. And here it is. So it starts within exon 1. And since the size is too small, it might end within exon 1. So let's check it. And I'm right. And one thing with the primers, you don't want it to be within 1 exon only, because what if your gene of interest expressed in other exons but not within exon 1? you know. So just try to optimize your primers to cover the end of one exon and the next exon, like 2 exons at the same time. So for the first primers that they recommended in here is within 1 exon, so that might not be a good idea for you to order these primers. So if you scroll down, there are many options, and I will choose the 4th one, for instance, because I look at the GC values. The first 3 around 45-40s are not optimals, so 50 is good. So let's see where they started, okay? And the forward primers start within exon 4, or actually start at the end of exon 4. So with the size is 97, it must end it with exon 5. So these primers work perfectly or match with what I've been looking for. Is it has the annealing temperatures within 59, GC values are 50%, which is good, and the self-complementary ratios are fair enough or good enough for me to accept those. And last but not least, this sequence, the primer sequence, should contains within one exon and another exon. So I will copy this to my notepad. And the reason why I'm doing this is I need to keep a record on myself. So I choose the 4 primer sequence recommended. So I mark it as a star over here. And I would type in a little note for myself that this exon cover this primer covered the end of exon 4. So maybe later on, when my primer doesn't work, I can go back to this notepad and I read, okay, so this is the reason why I choose this exon, these primers. So after you finished checking your primers and you make notes on yourself, you can go ahead and go to the last website, IDT, Integrated DNA Technology, and you can order your primers on this website. You have everything you needed, your primer sequence, the product size, and you can order from it. I hope this video will help you to make primers. Thank you and have a good day.